Hello everyone. Hi, this is Vineet Mathur. I'm a third year undergraduate student from NSIT University of Delhi. I'm a code enthusiast and I really love machine learning, artificial intelligence, deep neural networks, and I have done a lot of projects on machine learning and artificial intelligence. You can check out my GitHub profile www.github.com/pmathur5k10, or you can follow me on Twitter, the Mad Eye Guy, or you can check out my LinkedIn profile by the name Puneet Mathur. So let's get started. Today, what are we going to do? Today, we are going to create a web Python scrapper which will scrap Wikipedia article pages on the basis of user search query. Now, Wikipedia is a great website. We use it to search thousands of things every day. So, wouldn't it be so great to fetch all the data from Wikipedia article and have it on our system? Yes, it's truly possible with using Python web scrappers. So web scraping is a very basic technology which is used in almost every recommender system, chatbots, and various other ML and AI applications. So let's get started. So the aim of this small project is to get the 10 most and least frequently used words from a Wikipedia page that the user queries and return them with their frequency and the percentage of total word count. So let's get started. We will divide our task into 5 small steps. First, import dependencies. Second, get data from Wikipedia. Third, parse and format the data. Fourth, sort the data. And fifth, print the data in a representable manner. So let's get started. Step number 1, import dependencies. We are using 8 dependencies. That's right, 8 dependencies. You can look at the screen. First, Beautiful Soup. Beautiful Soup is a Python library which is used to pull data out from HTML and XML tag. Every data that is present on the web is either in HTML or XML format. When passing some data on web, we do not want HTML tags and XML tags to appear or come with the data. We want just the text appearing as it is on the screen. So we use Beautiful Soup library. Second is the request library, which handles the URLs from web pages. Request is a very popular library having over 7 million downloads every month. That's huge. Third is re. Re library is used for string manipulation, for concatenating strings and splitting strings. Then we have the operator library. Operator is a regular Python library which has various arithmetic operations like addition, subtraction, multiplication, and graph term. Then we have the JSON library, which is used for formatting and passing data in JSON. JSON is one of the very easy ways to pass data because the complete data is in the form of array of arrays. Next, we have the sys, used for system calls for user arguments. This is primarily used for getting in input data or throwing out some output data. Next, we have the tabulate. The tabulate library over here has only one purpose in a complete scrapper, that is to get the parsed, formatted, sorted, and finally output data in a tabular format, along with their frequency and the percentage of total word count. Lastly, we have the stopwords library. A stopwords library is a revolutionary library. When analyzing data, we come across various words like is, and, the, which we do not want to have in our data analysis. We wish to skip them. This is critically important for natural language processing, and hence stopwords library is used for this purpose. So let's get started. To make this Wikipedia scrapper, I have used 4 helper functions: get word list, clean word, third, create frequency table, and lastly, remove stopwords helper function. These 4 helper functions have been used subsequently in the scrapper, which we will deal as and when they are required. A very famous and accepted practice while writing Python code is to use the helper function assuming that they are already written. This makes their functionality very clear, helps the programmer understand what needs to be the argument and what has to be returned. So we'll be following those recommended practices over here too. So let us start talking about the Wikipedia API. So Wikipedia provides us an API to search for all related Wikipedia articles with respect to the user query. For example, here we have used Wikipedia API link, which is https en.wikipedia.org/w/api.php, and along with this we have three parameters. Format is equals to JSON. Format is equals to JSON tells the API to return the data in JSON format so that it is easy for us to read and for the scrapper to parse. Next, we have action is equals to query and list is equals to search, which tells the API link that we wish to provide a query and search the possible articles. Lastly, we have SR search is equals to, and after that it has been left blank. Basically, this is place where we will be putting our user query. Next, we have the Wikipedia link, that is a regular Wikipedia web page URL, that is https://en.wikipedia.org/wiki/ whatever the Wikipedia page tag we wish to pull from the web. So let us first talk about the input part. Len sys.argv gets the input from user. If this input is less than 2 letters, this input is not acceptable. You cannot search for something which does not exist or is too short. For example, letter A, B, or C on Wikipedia. So we have created a check, the first check at this point to ensure that the input data is a valid query. If it is not, the script is terminated via exit, and if the user query is genuine, it is stored in string underscore query variable. Okay, so once we are over with the input part, if the length of the input string is greater than 2, the search mode is activated to true, else it is left false. Next, URL is equals to Wikipedia API link plus string query. The string query that we have got from the user plus the Wikipedia API link that I have shown you a little time back over here is concatenated to form the actual URL. Now, what happens with this URL? Let me show it to you. This is the API, and we have concatenated the user string apple with it. When we search for it, Wikipedia API returns JSON format data. Here it is. It lists all the possible Wikipedia page articles related to the user query over here, which is apple. Now, understand this thing that this is very important. When you are searching for apple, what do we mean by apple? The system does not know which apple we are talking about. Is it the fruit apple or is it Apple Inc., the iPhone manufacturer? We need to remove this ambiguity, and hence we first request all possible Wikipedia page articles that are related with a particular user query. So over here, we see apple, and the description given is a promiscuous edible fruit of a temperate zone deciduous tree, which is right. We are searching for the fruit apple. So here we have this article link with index 0. Let us get back to our script. So we have this URL prepared. Now I'll be going through the try exception part. Why do we use exception? Basically, whenever we handle web data, there are a lot of chances of this scrapper ending up in an exception. The exception can be due to server does not respond. It may be because the Wikipedia page does not exist anymore. It may also be because the user string is invalid. So for all such and more such cases, we need to have a backup option which is given by try and exception. So if this thing does not work out, we have this except which prints timeout server did not respond. That is, the query could not be performed and hence there is no output. Well, in case the try works, we use the request library, the get method of request library, to fetch the URL from the web, and all the raw data is stored in the response variable. Now, this raw data may not be humanly readable, so we need to convert it into a humanly readable form, which is a UTF-8 form. So we need to decode it in UTF-8 format and then use the JSON library to format this data in JSON. So we store the JSON formatted data in data variable. So at this point, we end up with something like this. Now, the Wikipedia page tag is extracted from this JSON data by using data query search index title. So we are getting the wiki tag of the first data item by title, and which is stored in Wikipedia page tag variable. Next, the actual URL of Wikipedia page that we are searching for is created by concatenating Wikipedia link plus Wikipedia page tag. Wikipedia link plus Wikipedia page tag will give us something like this. Here we have n.wikipedia.org/wiki/apple. This is what we were searching for, the fruit apple, the Wikipedia page relating to this fruit apple. Now that we have the Wikipedia page with us, we use our first method, getWordList, which passes the URL and returns a list of every word present on the Wikipedia page. Next, we use the method createFrequencyTable, which takes in argument the page word list created just above and returns a hash table containing every word with its frequency count. So the key is the word in the Wikipedia page article, and the value is frequency of that word. Now that we have this hash table, we sort it to get the sorted word count min and sorted word count max. The sorted function takes in 3 arguments. The first is the item which has to be sorted. The second is the key, which is operator.itemGetter. This is why we use the operator library of Python. And lastly, the reverse. Reverse, if true, gives a descent. Reverse, if true, gives the sorted list in descending order, while if it is false, it gives the sorted list in ascending order. So we have created 2 sorted word count lists. One is minimum, the other one is maximum. The first one has a list of words. So the sorted word count min is a list of all those words that we have extracted from Wikipedia page article, sorted in ascending order, while the sorted word count max also has those words but sorted in descending order. Next, as we had put the search mode is equals to true, the sorted word count max and min will now be fed to the remove stop words function, which will return a list of pair having all those words sorted in their respective order plus their stop words removed. Going further, I've created a for loop which calculates the total sum of frequencies of each word. So this gives us an idea of total number of words on the Wikipedia page. Next, now one thing is very clear, that we may now have thousands of words in our list, but do we actually need those thousands of words? Practically, whenever we use these scrappers in recommendation systems or in chatbots or for any other practical purpose, we do not need to have thousands and thousands of words. We just need to have 10 or 20 most and least frequently used words. Hence, we cut our list to contain only the first 20 least and most occurring words. Finally, we calculate the percentage of total words each word is and append that percentage to the end of key value list. Now our data is ready to be output. We just need to add the headers to the table so that it becomes more representable. So I've created two variables, print headers max and print headers min, which contain their respective headers, words maximum, words minimum, the frequency, and percentage of total words. Finally, this tabulate library is used to create a table containing these words along with the frequency and percentage, and this table is printed. Now that we are done with the complete scrapper, but we need to discuss the four functions that we had described earlier. These four functions are actually performing a majority of our tasks, and hence we need to see how they are going about. So here you see the very first function, getWordList. This getWordList takes in the URL. It initializes an empty list known by wordList. It uses the get method of request library to pull data from the URL and saves it in the source code. So this source code may have a lot of characters, including text. So we just need the text part of the data that we have pulled, and hence only source code.txt is saved as plain text. Now we have beautiful soup doing its work, which takes in plain text as an argument and LXML and returns soup returns only text data devoid of every HTML and XML tag in the variable soup. Next, we run two for loops. The first for loop checks if the word is actually text. If the word in soup variable is not text, it is skipped. If the word is found, it is converted into lowercase and then split. To understand this thing, that our data may have different kinds of words. For example, fruit starting with capital F and fruit starting with small f may both be present, but these will not be considered as same words if we do not convert each one of them into either lowercase or uppercase. It is practically advised to convert each one of them into lowercase so that we may not have conflicting frequencies. The words are converted into lowercase and split and stored in variable words. The next for loop cleans every word in this words variable. If the word still exists, it is appended to the word list which was created earlier and returned. Now let us look at what happens in this clean word function. Basically, the clean word function uses the relibrary which was used for string manipulation, the sub method of relibrary which deletes every other character except capital A to Z and small a to Z and spaces and returns this clean word back to the calling function. The third function that we created was the create frequency table. It takes in the word list that was created just above. It creates and initializes word hash, which is a hash table. A for loop is run through the word list. If the word is present in the hash table previously, its frequency is incremented by 1. If it was not present previously, a key is created with that word and its value, that is the frequency, is set to 1. Once this hash table has been created, it is returned to the calling function. We come to the last function of our scrapper, that is remove stop words. Remove stop words is a directory. Hence, every stop word from this directory is stored in our variable stopwords total, which is called by the method get stopwords en. A list is created by the name temp list. Each key value pair in the hash table is searched. If it is found in stopwords, it is skipped. If it is not there in the stopwords, it is appended to the temp list, and this list is returned to the calling function. Now that we have seen a complete scrapper, we'll just go through the demo to see actually how does it work. So here I have Python Wikiscrapper dot py pple. Oh, sorry. There we go. So come first, come first, come first. Here we see the maximum words with their frequency and percentage of total, the minimum words with their frequency and percentage of total. As you can clearly see, the minimum word percentage does not exceed 0.03 percentage. Even the maximum word frequency is limited to 6%. But why does this thing happen? Basically, the Wikipedia page article consists of a lot of stop words which were removed in our scrapper, and hence the percentage is quite low. We can try another example. Python wikiscrapper.py. Now, as a fact of matter, if we wish to search for a term which has multiple words, we need to concatenate it with an underscore. For example, let us search for Donald Trump. Donald underscore Trump. So here we have the words with maximum frequency and words with least frequency over here. So guys, thank you for watching. If you wish to check out other of my projects, you can go to my GitHub profile www.github.com/pmathur5k10. I'll keep on posting cool videos. Thank you. Hasta la vista. Goodbye.